Welcome to this WEGreen workshop. So my name is Juncal Alonso and I am the project coordinator of SWForum, which is the CSA, which is organizing or co-organizing this workshop, also in collaboration with GECON and with the support of HUB4CLOUD. I don't want to waste much time talking about SWForum, just some insights of our CSA, and so that you have a little bit of context of the project which is organizing the workshop. So as a CSA, this is our main objective. We want to raise awareness and strengthen the competitiveness of the European software industry. And how are we trying to do that? Okay, so our main aim, and indeed we have the name of SWForum, is to create this sustainable forum for the different stakeholders being part of the European software, let's say, community. And when we talk about this sustainable forum, this has two, I would say, two pillars. On the one hand, the conceptual forum itself, which is the community building, creating this community, engaging the fellows, providing some governance structure, because we want this forum is long lasting. I mean, it remains after the project ends. But we also have this tangible part. So we have a living platform. We have this online forum where we provide this space for engagement, and we have this tool to support so this forum and the activities with respect to this forum. So this is the main objective, so the big one, and then we can this can be broken down into 4 more specific ones with related key results that will help us to achieve the objective. So the first one is to promote this cross-fertilization between the different stakeholders, industry, researchers, practitioners, policymakers. And for that, we are organizing this series of what we call cross-fertilization workshops. And indeed, WEGreen workshop is one of these. And indeed, it's the first one where we have the opportunity to meet some of the people of the community in person, so we are very glad for that. These are focused, I would say, topic focused workshops, and the topics are relevant to our community. In this case, we are going to talk about green engineering and sustainable software. So as a second objective, we want to create this self-sustainable forum. So this is a long-lasting initiative, or that is the intention. And for that, we are creating, or we have created the governance structure, and also the business model for the forum. We are promoting this fellowship program where the different stakeholders can join. We also provide this living forum with the online platform and all the functionalities there. And then we also are providing and creating also in collaboration with the community we are creating here in SWForum some research and innovation roadmaps that will end up with policy-related recommendations for the European Commission in the context of software technologies. And of course, as part of these roadmaps, we have the landscape reports where we analyze the current situation, the different stakeholders that may be relevant, and these kind of things. As a CSA, we want to support also the research and innovation projects. They are running now for or related to software technologies, and for that we have a set of services. I won't go much in detail into them because you can find them, a description of them, and indeed you can access some of these tools through our webpage. So we have the project draft, which is like an iceberg view of all the projects, and it provides some specific relevant information about the projects. It categorizes them, classifies them with respect to a specific taxonomy, so it enhances the visibility. At the end, it enhances the visibility of the project, as well as the project hub, which is a screenshot. You can see a screenshot there. all these services are also accessible to our webpage. So I will go in detail. Another asset that we provide, let's say, and we are building as part of SWForum is this MTRL methodology and let's say a tool for self-assessment of the project. So with this, what we want is that the projects are more prepared, that they can be more prepared to give the jump into the market after they finish. So to provide some guidance about how to move or to go forward once the research and innovation projects are finished. And that's it. We are organized into 3 main macro activities, which are mapping and cross-fertilization. The WEGreen workshop is part of this macro activity. Then we have the road mapping and governance, and engaging, of course, because we are a CSA, we need to create this community, and we are continuously engaging the different stakeholders. And that's it. We started in a very, I would say, complicated time for a CSA, because when designing the CSA, we knew nothing about COVID-19, and we indeed started it in the hard times of the COVID, I would say. So it has had some impact, and we had to rethought our, the approach, let's say, and how to create this community from this or with this situation and everything being online. But I think we managed it at the end, and now we are moving more and more to this at least hybrid events and hopefully more face-to-face events. We are 5 partners. You can find the representative of them today there in the workshop. So we have David from the University of Oxford, Elisabetta from Polimi, Mark is not there today, but we have Julie from Trust IT also in charge of our communication and dissemination tasks. And there it's me from Technalia. So thank you very much, and I hope we have a very instructive and very interesting talks today. And I'm sure we'll have them.
Thank you, Junka. Sorry, there is some echo here, so we need to figure out how to do it. But I think the first keynote is David Kaiser. And so David is focusing on assessing the environmental impacts of digital technology. And he's the co-founder of HUB4CLOUD, that is helping organizations to manage and reduce their digital impact. So let me see if I can give you the permission to share your screen. And but probably you already have it. Let me check. Yes, Julie is saying that you can do it. So please, David, feel free to share your screen and to start your talk. I am going to mute to avoid the echo here in the room. It seems that...
You turn on your speakers.
I need to turn on my speakers. David, do you hear us? Go to... Yeah.
You see, you'd never know that we've had all these years of doing all these online meetings.
Yeah, but
a good product would be to use like a simple box.
Can you hear me?
David?
Yes, can you hear me well? Hello?
We have now David. David,
Hello, hello.
the floor is yours, but we cannot hear you. Please share your screen. Thank you.
I keep mine. Okay.
So can you hear me, right? You cannot hear me. Alors.
We hear you, and we can see your screen.
Okay, you can hear me.
Yes, thank you very much. We can hear you now.
So thank you very much for the invite. Yeah, you confirm me that you can hear me. Everything is okay.
Yes, we can hear you,
Yes,
David.
yes.
Perfect. So what I want to present today is a little overview on how to evaluate the environmental impact of ICT, and more especially how to do it with an open approach. So using open data, open methods, and open tools. So my name is David. I'm preparing a PhD. I'm also the co-founder of HUB4CLOUD, as you said it, which is a company that is doing open source products to help evaluate the impact of ICT. We're also doing some reports for public and private organizations. And we have an open R&D approach where we make a collaborative construction of knowledge at Boa Vista, which is a non-profit organization of organizations, researchers, and freelancers, where we build open data, open methods, and open source tools to ease the implementation of evaluation of the environmental impact of ICT in organizations. So first, I think you should be all aware, you might be all aware of it, but what are the contribution of ICT to the global warming, So it is there is estimation that said that the impact of ICT are between 2 and 4%, which represent the equivalent of the public airlines impacts. And the more problematic is that these impacts are increasing, and there is estimation that said that the impact in only 3 years will be between 6 and 8%, which would be equivalent to the impact of car transportation. So the impact are high and they are increasing, and we need to invert this tendency very quickly. I just talked about the impact, the green gas emissions, but when we talk about ICT and other sector, we need to have a multi-criteria approach, not only taking into account only green gas emissions. For instance, in the ICT sector, we should take in consideration the use of fresh water, but also the use of non-renewable resources, for example, minerals. And this is very interesting because the minerals used in the digital sector are the same that the one used for the energetic transition. For instance, the mineral used to build a solar panel are equivalent to the mineral used in your smartphones. There is some similarities. So there is a competition between the two, and that's why we should take into consideration the mineral resources used in digital products and services. So how to evaluate them? You have to know that ICT is multi-perimeter. So you have to take into consideration the impact of end-user equipment, network, infrastructure, and it's also multi-step. You have to take into consideration not only the impact of the usage, but also of the manufacturing, the transport, and the waste, the disposal of those different resources. To do so, we have a method that is called life cycle assessment, which is a very well-known method in environmental studies. It's defined by an ISO, and it's multi-criteria. So with this methodology, you can evaluate not only green gas emissions, but also mineral depletion, freshwater usage, and so on. And it's designed to be on all the life cycle of the product. So it's not only taking into account the use phase, but also the extraction of raw material, the manufacturing, and so on. The main issue with life cycle assessment in the context of the digital sector is that there is not a lot of data available, not a lot of environmental data. The ones that are available are either not transparent enough, or you have to pay for it. And also the digital sector is very is very spread across, it's very opaque, it's not transparent. So it's very hard to model the impact of ICT and to implement life cycle assessment in the context of ICT. So this is some reason why we should make open evaluations, but I want to give you some other reasons. For instance, I believe that doing open evaluation is a democratic necessity because the impact evaluation will direct political orientations. So as a citizen, we should be able to audit and criticize the numbers that are being used in political orientation at European level or at state level. And also there is some plan of doing some environmental labeling at European level to label some products and services to label their environmental impact. And as a consumer, you should also be able to understand and to audit and criticize the way those labels are built. And there is a more basic also a justification for open methodology and open approach is the fact that the existing measures are very, very poor quality. You can see on the table the GWP, so the green gas emissions for screen manufacturing, and you can see that there is a factor 10 between the lowest impact evaluation and the highest, and it's per inches. I cannot explain to you why there is such a difference because the methodology and data used are not transparent. So if I want to evaluate the impact of my screen, I wouldn't know which value I should take. So know that you are convinced by the fact that we should do open evaluation. Is it possible to do it? Well, spoiler, it is possible. It's partially possible, but it's very hard. And I want to give you some resources and to show you the different to show you some example of project that tries to do so. So we have some allies who are working on open source methods and data and tools that I've put in here. And let's see an example with the impact of end user equipment. So at Boavista, we have built a platform which is called Data Vista, which aggregate all of the manufacturer declarations, the impact of the carbon impact of products declared by the manufacturer. So they are aggregated here, and you can play a little bit to see the order of magnitude of the different type of equipments. But the problem here is it's like open data because you cannot access the hypotheses that have been made to model the impact of the different products. So it is good to see the order of magnitude, but it's not good if you want to see the specific impact of a specific product from a specific manufacturer. Another example, let's talk about the impact of using a server, so the impact related to electricity consumption. So usually to model the impact of the usage, you multiply power consumption with an impact per kilowatt-hour of electricity. The impact of per kilowatt-hour of electricity depends on the place where you use your server and depends on the electrical mix. If your country uses a lot of coal, then your impact per kilowatt-hour will be greater than if your country relies on nuclear plant or renewable sources of energy. So to model the power consumption, you have several strategies. You can use a physical strategy. So you take your smart meter or your watt meter and you plug it at the end of your building or on your power supply, and you can model the power consumption of your server or infrastructure. But it's not very precise, and you cannot allocate the power consumption to a specific service, for instance. So to do so, you can use software sensor. I've put 3 of them, which are open source software sensor, which are able to request the power consumption of the components of a server and to report them. Some of the software sensors even are able to tell you that this service on this server can consume this amount of energy. So it will allocate the energy consumption to a specific process or a specific service. To have the impact of a kilowatt-hour of electricity, you have several resources. I've put in here electricity map, which is an open source tool that show you the live carbon intensity per country, which depend on the electrical mix. So it's available online. What about the cloud? So if I want to apply those open approaches in a cloud context, how can I do? Where do I plug my power meter or my watt meter? I cannot go to AWS and ask them to plug my watt meter, right? I can neither install a software sensor in a cloud context, because we are in a virtualized context where we cannot access the physical infrastructure that are behind the virtual environment. So software sensor won't be able to access the data from the components. So what we are trying to build, is an open science approach where we want people the community to build a database that aggregates some power consumption, some power consumption model. As you can see here, you have one for CPU, where we ask the community to give us some measure on the power consumption of Intel Xeon Platinum, depending on the workload of the CPU. And we can see that for Xeon Platinum, the trends are kind of the same, like they're very, very close. So we were able to infer a model for all the Xeon Platinum that can be reused. For instance, if you use a cloud instance that relies on a Xeon Platinum, you will be able to model the power consumption depending on the workload of your instance. So that's what we are trying to do at Boa Vista, and to gather more of those data to have more consumption profile depending on different component characteristics. To finish, I want to talk a little bit about how to model the manufacturing impacts, for instance, of server and of cloud services. At Boa Vista, we have found that and it's described in the literature, we have found that the most impacting part of the manufacturing process is the engraving process. So the fact of engraving a chip, the wafer, is the most impacting part of the process. The more the engraving is small, the more impact it will be, the more impacting it will be, because it will require more energy, more water, more resources. Yes, I have a slide here which isn't working. We have built at Boa Vista an API where we are able, from a CPU name and from CPU characteristics, to report the impact of manufacturing the CPU. You can send to the API the characteristic of the CPU, and then we can, from the characteristic of the CPU, we can infer the size of the engraving and infer the impacts, the manufacturing impacts. Sorry, my slide just broke. So to conclude with the different resources I've given you, you will be able to build a bad evaluation, but at least it will be transparent, right? So the conclusion would be like evaluation is important, but it's not like you can act on the environmental impact of your of ICT without evaluating it. So in the meantime, while we are trying to build tools and open source approach, you should keep in mind that the rule of the 5 R, which is refusing, reducing, reusing, and recycling, and returning, which is the framework that you should keep in mind when you want to develop or to buy ICT product or services. And I'm done. Sorry, I've tried to made it very quick.
Okay, thank you very much. Thank you very much, David. Is there any question here from the audience at home or here in the room? There are, Karim. I'm coming to you. You move here. Okay. And then Vasilios has another question.
Please go ahead.
Thank you for your excellent talk. Maybe I'll start with the first question, which is to do with Microsoft having developed a specific tool to basically estimate the carbon footprint of any user using cloud services. So maybe if just in case you are aware of that initiative.
Actually, I had a slide specifically on this topic, but I removed it because it was too short. Yes, so Microsoft and the other cloud provider are providing some softwares to evaluate your cloud impact. The main issue is that it's not transparent. So you're not able to know how they measure it. The thing is, Microsoft are the ones that share the most of their methodology. So I'm not going to criticize them over the others. And the main methodological issue is that it relies on monetary allocations. So it means that it depends on the amount of resource that you pay and not the amount of physical resources that you use. So it makes the difference. For instance, if I reserve a virtualized environment, if I don't use it, or if I use it at 100% of its workload, Microsoft will report to me the same impact. Okay, because I will pay the same amount of money for the reservation of resources.
That was precise. Okay, thank you.
Thank you. There is a question, I think, by Vasilios in the chat. Vasilios, do you want to speak?
Sure. Just to make an even shorter version of the question in the chat. I really like the talk. First of all, let me say this. But to cut to the point, when, for example, you are calculating the impact of the manufacturing of the chips, right? Who's gonna bear the responsibility of this emission? Is it the manufacturer? Is it the consumer that uses the device? Is it the provider that is using this chip to actually power their services? How do we avoid double or triple accounting in this case? Because they cannot all say, you cannot just say you are all responsible equally, here is all your impact.
It's a pretty good question. Actually, we have asked ourselves this question, and we have chosen not to respond to it. That's why we are having a life cycle assessment approach, which we try to contabilize, we try to account for all the impacts. We don't ask ourselves to whom is responsible for this impact. The thing is, we try to give open source tools and data to let people use them. And I think that it's a political decision. It's not a scientific decision. It's politically, we need to choose who is accountable for which impacts. And our tools can be used in either way, because we report the impact of manufacturing, usage, and so on. But like for our clients, we try to make them accountable for all the impacts, and because
I understand. Yeah, it's a
pretty good question.
It's a meaningful choice. Yeah.
Okay. Do you have other questions? Here in the chat. Okay, so I guess other questions will pop up during the discussion. Thank you very much, David.
Thank you very much for your invitation.
Yeah, so we will continue afterwards during as I said, during the discussion. But now it's the turn of Ilias Iacovidis, and Ilias is focusing on EU measures to improve the energy and material efficiency of the ICT sector. And so he is currently advisor of GECON2022. And so he's bringing the viewpoint, I guess, shared also with GECON2022. Ilias, can you share your screen? Do you have the permission? I guess so, because Julie has set it.
I can do that. So hello, everybody. Good morning. I don't know if you can see what I'm displaying.
We are, yes, now we see it. Great.
Good.
I'm going to mute, so please go start whenever you are ready.
So, good morning again. Thank you for the invite. I enjoyed, David, your talk, and maybe let's organize a talk offline to discuss some of the issues that you mentioned, okay? So, yes, David, actually, it's good that David spoke before me, so I don't need to go into measuring the impact of ICT, which is very complex. Huh? And one thing I want to stress that he also said, but let me stress it again, ICT impact is both on energy that you as a software engineers look at a lot, but very much on the materials. It's very much a physical material problem as well. So just to give you an order of magnitude, the footprint of a mobile phone. So if you take a mobile phone, the footprint of that, 85% is to produce it and to ship it to a user. So before the user even touches it, 85% of the footprint is gone. Now, as you go towards the servers, so iPads, you know, the tablets and the laptops, it's still more to produce than to use. When we get to the servers and equipment of telecoms, then it turns around and depends how many years they are used. It could be that the energy consumption and the CO2 from the usage is bigger than the production. But people forget that, and there is a lot of emphasis on energy consumption. Now, there is another figure that David mentioned, that yes, we are about 4% in Europe. So it's between, as I said, 3 and 4, but in Europe, we are closer to 4. In other parts of the world, they're closer to, you know, less than 3. That number to rise by 2025 to 8% is unlikely in our estimations. What will rise is the electricity consumption, but that electricity consumption is not linear with respect to CO2. So we estimate, we hope almost, yeah, that the electricity consumption will not increase the CO2. We work with a lot of companies. We work with the Climate Neutral Data Center Pact and 35 companies in the Green Digital Coalition. They all have their own targets to basically go to net zero 2040. So by 2030, they actually want to be net zero with respect to scope 1 and scope 2. And that's why that brings me to the question that was asked about the scope 3 and the multiple accounting. That is, as David answered, unsolved problem. We still struggle to see how to measure consistently, and then we'll see how to allocate. But at the moment, that is a problem for reporting of big companies and their suppliers, and the whole ecosystem. Like, where do we actually, and how do we count the scope 3, which is the biggest chunk of the ICT companies anyway. We have a new initiative, and that is called Digital Product Passport, that we hope to apply to some products, maybe not ICT in the beginning, where we will track, and basically we want to track the material, the subcomponents, the components, the product with respect to material flow, but also the CO2 flow. And that will give us, this digital product passport will give us a little bit of a better view and help the allocations later on. So that's just before I start my talk. Now I will try to go as soon as I can to the software issues, but the bigger picture, again, kind of repeating what David said, is that when people think of green digital transition, that's the key word, and those are the two pillars of the Commission at the moment, the Green Deal and the digital targets, and digital decade. Those are the two biggest kind of portfolios of today's Commission. We are looking at it, what exactly is this green digital twin transition? Twin, I don't like, but okay, those two transitions. If you ask yourself, what is the end result of the green transition? I guess you will all answer that. If you kind of try to answer, what is the scope and aim and goals of a digital transition? It gets a little bit trickier lately. In the beginning, when we started 30 years ago, it was very clear. It was well-being of humans, health and well-being and support, enhancement of human capability and better life, basically. I'm not sure that many people can say that now about the digital transition and all the things that it carries with it. So at the moment, equating them, so one became more of a survival, the green transition. The other is mostly focusing on one dimension of sustainability, and that's the economic. It's struggling with this kind of the social issues in the three-dimensional space of sustainability. And it just discovered recently that there is a third dimension, that's the environmental dimension of sustainability. So in this three-dimensional space, economy, society, environment, there is a lot of space for improvement. And there is not enough knowledge, and there is basically no scientific knowledge how to look at those three dimensions together for digitalization and how it improves these three dimensions at the same time without avoiding to do it on the expense of one of the three. So there is a lot of focus on the conflicts, and that's basically because it's much better measured. So we are looking for the keys where the light is. So we have the LCA, we have the measurements, we can estimate the energy consumption of data centers, we can estimate the kilos and kilograms of e-waste. So it's pretty easy to say there is a big conflict. Green is actually suffering from this digitalization. What is difficult to measure is the synergy, and that's where I would like to put your community a little bit to work. So yes, we will do, and we will have to clean our house, and we'll have to measure well what the footprint is, but we also need to start measuring what is the enablement. So instead of focusing only on the conflict, let's look at the enablements, and let's look at the emission reduction. What can we avoid using smartly software applications? And there are two issues on software. One is, what is the algorithmic optimization? So the processing and the power consumption is optimized with respect to running algorithms, especially deep learning of AI and others. So that's one issue, but that's very much confused with the hardware. So is it really, the software issues, the optimization, or is it more of the hardware that it runs on? And the second is how to use smartly software to reduce the consumption of any electrical or whatever energy consuming smart device. And there is a huge opportunity for improvement, okay? And that we still need, to measure and to scientifically explore. So just as a slide that is basically overview of what we can reduce is, what we need to do is in the ICT sector is, of course, the data centers. We have a big, a whole unit working on that. We have taken a target as a commitment. So Europe took a commitment to make our data centers in Europe climate neutral by 2030, net zero. Very ambitious. The big ones is not a problem. It's the smaller ones that are in the basement of hospitals, in local governments that are holding your passports and your medical records, that may not go to, to clouds and to big cloud providers that have their own wind farms and energy sources. So there is something that we need to do as Europe to help them to become greener. There is, of course, the problem of circularity of electronics. Just in Europe, we are the worst in the world. Per capita, it's more than 16 kilos per person of e-waste per year. It's huge. So we need to sensitize our public, maybe even just changing, if we all could change our mobile 1 year later, that would just, instead of changing every 2, change it every 3, or if you change it every 4, change it every 5. Everybody just do it 1 year later. It corresponds to about 1 million cars of lifetime emissions of 1 million cars in Europe. So it's huge impact on what we do with our end user devices. We work on CHIPS Act, as you've heard. We have this new CHIPS Act, and we're looking at how to improve the energy efficiency. And of course, we have a big work now on what to do with the telecoms and telecommunications. So that is ongoing work on greening and saving energy on ICT level. But again, what can we do with ICT? Much, much more. And our estimate is let's make the 4% of the footprint of Europe, let's stabilize it and drive it down to 3%, drive it down to 2%. So we're talking in total emissions, let's save 1, 2, 3%. What we can do with software, if we apply it and govern, use it, design it and govern it properly, only under very special conditions, of course, we can actually cut more than 10%. So there is a missed opportunity and we are not doing it. We are not doing it. So at the moment, there are some estimates that whatever our footprint is, we can enable, but we can do 5, 10 times more maybe. So the potential is there for us to realize and to try to reach. Of course, it's a lot of software. Huh? It's a lot of software that is sitting in the 5G base stations to put them in sleep. So telecom equipment can be much more efficient if there is a software that can, understand when it's needed to work, when it doesn't, and just switches it off. And that's for any electrical appliance. There is a possibility for reduction in the mobility, mobility as a service, precision farming, and things like that. But I give you a word of warning. Let's take smart mobility or precision farming, for example. We can say, yeah, look, with the software and with the platforms, we can provide people with their own personalized mobility service, as mobility as a service. We don't need that everybody has a car. So take a big, huge urban area. There are 500,000 cars in that urban area. I mean, we're talking about huge city. I can do the work with 5,000 or 1/10 or even less of the cars. They are electric. They will be autonomous tomorrow. They take all these people from A to B as before. They are electric, so clean air, no CO2, much better as a service for mobility. Now, that sounds like fine, but let's look at these conditions under which we are in the positive space and which once you cross those, you're getting into negative territories. So for example, if you don't make sure that people don't buy their cars anyway, in addition to mobility as a service, you're already negative. If you make people to take those electric cars instead of public service, I think you cannot beat public service from the environmental point of view. And if people start, the rebound effect would be taking objects and putting objects in these cars and sending it across the city to their friends, you start having a negative territories very quick too. So of course, all these applications, same thing with precision farming. If you just throw gadgets at farmers, they will never recuperate the footprint of making those gadgets and running those gadgets if they don't know how to use it properly with a minimal kind of frugality principles. So there we need completely new business model. We should tell the manufacturers of fertilizers and let's say pesticides to be digitalized and offer service rather than throw the gadgets at the farmers. So there are many conditions under which ICT must be kept in order to be kept positive that are not yet obvious. And this is the work that we do in Green Digital Coalition. So David, we will talk about some of the things. Maybe there's involvement also of Gauthier Roussier. Well, maybe you know him. He's also doing his PhD like you. So we're looking at how to measure and how to measure a solution, not macroeconomically the ICT. So give me a solution that has so many sensors, so many IoTs, a laptop or drone. So we know exactly what the solution is about. We measure its footprint, we measure its enablement, the avoided emissions, and then we try to estimate the net effect. And if the net effect is positive, let's give that information together with the guidelines, how to keep it positive, to financial actors, to governments, to deploy it under those conditions for these sectors. Energy sector, mobility sector, construction sector, agriculture, manufacturing, you name it, smart cities. So this is the approach. It's a solution-based approach. And every solution is a mix of technologies. And software is really a big part of it. Okay, so it's of course telecoms. It's of course, some kind of a sensor IoT, but there is a software, and that software will make a difference to optimize that. And that's basically a message for you. Now, if you want to go into data centers per se, I have a slide, but I would not want to go there unless you ask. Yeah.
Sorry, we have again the square in the middle of the slide.
Ah, there is something. Okay. Better?
Yes, yes. No, yes.
Yeah, so we do have a lot of efforts on telecoms and data centers, but I think it was covered well by David. So maybe let's go to Q&A. Maybe we save the time better for in Q&A than me continuing talking.
So thank you very much. Do you have questions for Jan? Sorry. David is coming here to ask a question.
Okay.
So it's a bit of an abstract question, and I'm gonna pick up this hopefully on the discussion later on as well. One of the questions to the previous speaker was, of course, about scope 1, 2, and 3. How do we start thinking correctly about attributing scope 3 to software? So actually, when you start developing software, how do you actually correctly attribute scope 3 emissions to software? Is that the developer's lunch? And you mentioned, Ilias, about all of the importance of really understanding all of the contributors. And David mentioned this, of course, from the point of view of data centers and services. But we often, we don't correctly think in the round about the software that sits on top. You highlighted optimization, but how do we think about scope 3 in terms of software?
Especially, just to add to this, especially since it's becoming common practice for software vendors to offload their footprint by basically outsourcing their software to a third company and saying, well, now it's scope 3 for me. So, I've met my target emissions, right?
David, you want to go first? That's really, it's a difficult question. I mean, the software, depends, your software developer, you run it on some kind of a hardware, because the software so far is kind of in the, people think of it as a virtual thing. So they don't really think about scope 3 until you see the whole operation of the software development and training and then inference, just using. And then it comes with a package, and it comes with a tail, and that tail has to be attributed. And that at the moment is what Vasilios said. It's kind of dumped on others, that I'm just in the software and the hardware belongs to somebody else because I'm running it on somebody else's. So it's somebody else's problem. Unless it's a big company and they have their own and they know then how to count it. So unless it's like an Oracle or, it's Cisco's and the big ones, IBM. So then they do that. But for a normal SME kind of software developer, this is somebody else's problem. At the moment, we have something called Digital with Purpose as a framework of measuring sustainability of SMEs. And I'm really disappointed. Any SME, we try to ask them, for them to understand what your footprint is, they are completely lost. They don't even understand what you're asking. So at the moment, we have a bigger problem than, yours is already kind of a university level postgraduate question. We have not even passed the elementary school with respect to this. Yeah.
Cool. Karen?
We are getting another question.
It's not a question, but it's certainly to follow up what you just said, and following up on David's question. I think it's always to do with the entire life cycle of software being embedded, certainly with energy consumption, for example. We would have to think about how to design, for example, software from day one that is in itself energy aware. There is an education process out there. There are a number of EU projects 6-8 years ago that actually did some very interesting work in that aspect, especially when it identifying, for example, patterns when it comes to software engineering. You know, we just write code and you have a number of patterns is actually very well known. And you can have, for example, a carbon footprint or a power consumption. I think there is certainly scope to maybe start educating people, but that's again.
I mean, you know better. Are there any classes in for software development on the processing optimization? So kind of the frugality in the code development, because most of the people think, oh, the footprint has to do with hardware. I mean, I run it on a clean data center, I'm fine. I run it on a dirty one, that's the problem. But is there something that the software engineers take upon themselves of, you know, in the past when we had not much memory, you know, I remember 60s and 70s when the Russians were struggling with the power, they were really mathematically the optimal guys to make the smallest number of code for the need they wanted to serve.
Well, the historic community that, of course, have been doing, guys. So, the historic people that have, of course, been doing this as part of their everyday bread and butter, of course, are around high performance computing, where, you know, every flop matters, because, you know, when you, and this comes back, I think, also to people like Google and things like this. You know, if when you're optimizing a piece of software, you make a 1 or 2% improvement, it doesn't really matter if you run it 5 or 6 times. But of course, if you run it 100 million times, all of a sudden that is a huge impact that you've actually managed to save. And there's a lot of really interesting questions about methodologies and optimizations, that it's not just about, you know, performance gives you optimization of how well a code works, but also there are optimizations. And for example, the green 500, which talks about how well high performance computers actually their flops per watt, i.e. the amount of energy they use for a computation.
Carbon intensity of the processing. Yeah.
Exactly. Well, carbon intensity of the of the system, and that's a really interesting. You know, that then comes back to what David mentioned earlier about thinking about the whole system. You know, the green 500, you know, in comparison to the top 500, talks about flops per watt rather than the amount of flops you can get through. There's a lot of really interesting questions, and maybe one that we need to think about more greatly about how optimization packages are often focused in one area, and we need to think about them and how we can work with their developers to be broader optimizations. You know, yeah, I might make a piece of code 5% quicker, but I might make it 15% less energy efficient because I make it use more resource, for example. How do I do those trade-offs?
But you need to understand also the, you know, the hardware and you know, where is it going with respect to the emissions of the, you know, the processing. I mean, it takes about the same amount of energy to process or to send, because there is also optimization. Can it be done locally? So we talk about edge computing now. How much of a communication the whole application wants. So you need to kind of have in mind the whole system that you apply to, and think in terms of net effects. So that's something I wanted to bring to you. Don't think only on optimizing energy. If there is a need for, you know, maybe spending a little more, but that would really serve the avoidance of emissions, think of net effects. And that's something new that people still struggling with, what a net effect of my application is. So system view and net effect is something what I want to bring on the table today.
What I would like also to ask is, in software engineering, there is, I think, one problem all along, is that there is no modeling of resources that they are using below. I don't know a lot about it. Maybe there is some kind of people that are doing something like this.
Modeling
resources.
Well,
The resources you are
yeah.
using, this is not only energy, it's material,
Yeah.
it's nodes. That you don't have that in software engineering normal. Maybe there are some people that have begun to treat it, but how can you deal with if you don't model it? You model all the other things.
Yeah,
The basic
yes,
resources,
yeah.
where they are.
I guess what David is doing is a prerequisite for this.
There is a gap.
Yeah.
Infrastructure people, they deal with resources, but you get so engineer, they are lost. Somebody is dealing with them, but we don't need. They are.
Guys, we have 2 other presentations and then we have the panel. So just as David was saying, let's thank Elias and then we will get back to the panel and to the discussion. But now we have the presentation. Let me remember if the first one is, Vasilios, the first presentation by Vasilios, and then the second one by David Mitton. So please, Vasilios.
You should be able to see my screen now, right?
Yes.
All right. Despite being a bit over time, I'm really happy about the previous presentations and the discussions we had, because they really touch upon a number of things that we plan to do with this project. First, I'm Vasilios Andrikopoulos. I'm assistant professor at the University of Groningen. I'm with the software engineering architecture group. So we're looking at it from a more traditional software engineering perspective. I'm here to talk about a project that literally just started. We had our kickoff meeting last week, together with the Vrije Universiteit, the Sustainable Systems Group led by Patricia Lago, and funded by the Dutch Science Foundation, on how do we build sustainable services, software services that are operating on the cloud. If I want to put it in one side, the elevator pitch. Even though both groups, both us and there's a DS2 group in Amsterdam has done a lot of work on exactly the topics we were discussing before, energy management, monitoring, and so on. They gonna just open the scope a bit up and introduce a framework that we're using, point of view that we're using in software engineering to talk about sustainability as something that has 4, or if you ask some people 5, I'll use the 4 dimensions here, which is, yes, the environmental one, things that we're just discussing, but also the other aspects of sustainability that we were hinting at, but not really acknowledging in the discussion before. That is the social aspect, that how sustainable are the systems for the communities that are using them? How do they promote their longevity, right? And then the flip side of this, which is how technically sustainable, user thing in terms of maintainability, are the software systems building. Is the more traditional software engineering perspective, right? How long can the systems live in time? And of course, the economic system, how financially viable are the systems. The systems that we talk specifically in this project are referring to services provided by software as a service providers. And it's a conscious choice because we we build on the fact that SaaS providers are a prime example of being what's known as prosumers. Like they are both providers and consumers of service, because the vast majority of them, with the exception of the beasts like Salesforce, for example, do not have their own cloud infrastructure to actually operate. So they usually build on top of something, right? They build on one of the hyperscalers, or they build on local providers, local cloud service providers to actually offer their service. And what we are planning to do this project for these people is to build upon a framework that we discussed rather briefly, I have to admit, but needs to be elaborated. It's going to be elaborated in the following years. The sustainability aware architecting framework as a way of guiding software architects, so the people that are making the decisions on how the software looks like and how it interacts with its environment, its users, and with other software systems before it goes down to actually being implemented, across these 4 dimensions. The SAF framework consists of two major citizens, right? The one is the stakeholders, who is involved and who has what to gain or what is being interested for across different dimensions. And the other part.
Vasilio, so I think that when you move your hands, maybe you touch the microphone and we
Sorry,
don't
yeah.
well.
Okay, is this better? I stopped using my hands,
Yes. Now it's much better because it's a bit complicated to hear, to understand.
I see. We're hitting all the Mediterranean cliches. Okay. I will. So what I'm saying is that we acknowledge a number of stakeholders, each one with their own role in this. We have already prior work coming mainly from the S2 group, which is on how to actually document and support architects and decisions. And what we are adding to this mixture is the fact that each one of these dimensions is going to be approached through a set of indicators that allow us to, and in the interest of time, to summarize as indicators that can work in a positive relationship with each other. For example, starting at the bottom, looking at how the building and operating of a system returns expenses upon it, to how efficient is this return of expenses, and assuming that we can actually have a positive return of expenses, we're in the black, right, or in the red. We are basically making some positive outcome in terms of this indicator. Then we can actually use the generated revenue to actually build more dependable service. I will not go into details because I will definitely run over time. I'll just go to the main propositions of what the service is, what the project is supposed to look into. And that's basically building on the idea that these indicators representing basically each dimension can actually be used in a positive way to create systems that are self-sustaining, right, across all dimensions. Of course, there are negative feedback loops between dimensions that need to be acknowledged and need to be taken into account, but there is prior work on how to avoid or how to mitigate this kind of negative feedback. So we'd like to think of this specific set of indicators as being in a positive feedback loop with each other. And this is how we enable this self-sustaining. Of course, since we are software engineers and we're both coming from groups with strong empirical tradition, we would like to use different search methods to do so. But our focus on that project is actually on collecting evidence. So we are not planning to come up with a list of prescriptions or suggestions. We are mostly looking into how this phenomena actually exists and they're out there, but we never acknowledge them and we never record them. And that's where I'm gonna stop again in the interest of time.
Thank you, Vasilios. So let's see if there is maybe a very short question, and then we could move to David's talk so that we can have some time for the discussion later on. So any question? Quick question?
Can I ask something that I meant to ask before, but this software, is it kind of hardware dependent? I mean, can these ideas also apply to quantum computing?
We are not really, the answer is yes to the later part. What we're looking is purely at how software is being designed and eventually written, right? We don't have dependencies on the kind of underlying infrastructure, underlying hardware. What we do really build on is the relationships of offering it as a service, which is a fundamental relationship for cloud computing. And of course, the whole concept of being having the capability to outsource your infrastructure to a third party, right? Because that comes in relative for the environmental.
Yeah, and that's basically what many companies are being asked to do to save, because everybody has to report, everybody's looking how to minimize their own footprint. The digital infrastructure of a organization is now targeted, although after trips, like the cars and the buildings of a company, now they look at of course, their IT department.
Yeah.
So they virtualize, they kind of give it. And then we come back to the question that the big companies, including Microsoft, I've seen it, I was demoed, can measure, if you come to my cloud and I take over, this is the savings you can do. And they actually do it, personalized savings of CO2 for you if you move to their cloud.
Yes.
Now, David is right. Who knows where they are running these things now? Because this kind of one measure, but they have clouds in many different countries.
Yeah.
So how do we actually know how to measure this?
Yeah, the way that, well, this is not part of this project, but the way we have looked, at least on our side, on this is to actually try to get the data. Like David was basically bringing up the part of that the whole thing is opaque, right? The methodology that Microsoft is applying is documented, but still the data are missing. So at least on our side, the only part that the only solution we could see is to actually go to smaller cloud providers and ask them to give us access to the data themselves. Right?
They promise that they will do that. So as you know, there's the OVH clouds and the data center climate neutral data center pack. They are promising that they will measure very concretely. But
the way that we solve the problem, at least in our case, is to ask a very big customer of this provider to actually enable access for us. So we did it by finding the right client that they could not afford to lose if, you know.
And we have the same problem as a commission. I mean, we have estimated our own footprint. Of course, after COVID, it's completely different. But before that, it was the trips, it was the journeys of the armies of people that we bring every day to meetings to Brussels, or us traveling. That was like 56%. Then the buildings, and then only ICT, which is kind of less than 10%. But now, after COVID, everything is virtual. So the journeys are gone. Nobody's coming. Everything is virtual. And the footprint is now in video conferencing and in the ICT.
Yeah.
Okay, so let's postpone the discussion to after the next talk. So thank you, Vasilios. Thank you also, Elias, for the discussion. And let's move to David's talk.
Hello, everyone. Can you see the slide? Hear me okay? Good?
Yes.
Excellent. My name is David Mitten. I'm going to talk you through a paper that I co-authored in Joule that came out last month. I've been in the tech industry, in tech startups, for about 15 years, and will shortly be joining David Wellham and his group at Oxford to continue researching sustainable computing, which is my broad area of interest. Now, in this paper, we went through basically every single data center energy estimate since 2007 up to 2021, and that allowed us to pick out 46 publications that have 258 estimates. There are many more publications than that, but our inclusion criteria was pretty strict in that we were looking for original estimates with calculations that we could get into the methodology and analyze. And our key focus for this work was looking at the sources, because this really is the underlying foundations of, well, all scientific work, but in particular estimates for data center energy because of how the methodologies work. So across those 46 publications, we looked at almost 700 sources, analyzing them and breaking them down into different categories. And the broad conclusions of the work is that a large part of the literature is pretty unreliable. The methodologies have particular challenges and the sources have particular challenges. For example, a lot of the data relies on peer-reviewed reports, and there's also a significant reliance on private data, particularly from IDC and also from Cisco for the networking side of things. And it was particularly interesting to see the challenges in the methodology and just how many of the sources that were referenced were either referenced with insufficient detail, so we just couldn't find them, or they were referenced but were no longer available. 11% of them were linking to websites which just didn't exist anymore. Now, this is a particular problem because of the range of the data center energy estimates. This chart shows the ranges over 2010 to 2030 for the different estimates. As you can see, it's getting larger, but it's not necessarily getting larger because the amount of energy consumed is going to increase. It's getting larger because of the underlying source challenges and also the methodologies. And the reason why we wanted to look into this is because of the difference in the different estimates is over an order of magnitude. So from 146 terawatt hours of consumption in 23 to almost 2000 terawatt hours. And we actually excluded some estimates from this chart because including the largest estimates, which go over 8,000 terawatt hours, would just break the visualization. Now, in the paper, we've got all the underlying data. So if you want to have a look at what that actually looks like, you can download that. But being able to deal with this from an energy system perspective it's quite different building an energy grid that can deal with even a couple of 100 terawatt hours to dealing with almost 10,000 terawatt hours of energy consumption. Now, there are a range of different problems that we highlighted in the paper, but in particular, there were some significant differences between how methodologies are used to come to these estimates. And there are three different types of creating data center energy estimates. The first of these is bottom-up, and this is where equipment specifications are used and the install base numbers from shipments of those equipment are combined to create calculations for how much energy is consumed by all the equipment that has been manufactured and shipped and is modeled to be installed in data centers around the world. And then for future projections, trends are used from industry analysis to understand how much more equipment is going to be shipped in the future. The limitations of this are the availability of those install base and server equipment values, because the majority of this data comes from private organizations, and IDC is the most commonly cited source, and their data is not publicly available, which makes it very difficult to reproduce and analyze the underlying data. The second type of methodology is top-down, and this is where data from typically government, but also organizational data from things like telecoms companies is used. And then that is allocated over a number of subscribers, particularly when it comes to looking at network energy and mobile subscribers. And then there's an understanding of what is the relationship between the demand and the energy consumption. The challenge with this, again, is just the accuracy and the availability of that data. Often you have to rely on either data that's been provided, again, privately to the researchers, or is provided by a private organization that might not necessarily provide the level of transparency that you need. And then the third type of methodology is to use one of those two first methodologies as a baseline, and then to apply a growth rate to extrapolate the numbers out into the future. The main assumption here is that there is a relationship between the demand and the energy consumption, and that is typically done on a data volume basis. And you'll often see energy intensity figures of kilowatt hours per gigabyte of data. And the main assumption there is that link. When we compare these methodologies, you can see that there's a significant difference in the range of the estimates when you compare the extrapolation and the bottom-up methodologies. Now, this is somewhat to be expected, because if you're extrapolating from a baseline number, then you can expect it to increase. But the range of these estimates is pretty extreme. The main thing that stands out from this is the willingness of researchers to make predictions into the future. With the bottom-up methodologies, they typically only look out a couple of years, whereas the extrapolation-based methodologies will go out quite far into the future. Another challenge that we saw was just the availability of some of the data. This is a diagram of the cascading sources through several different publications, using the Shift Projects report as an example of a particularly poor methodology and very bad transparency. If you look at the lines, the orange highlight is where the data is not available, or it couldn't be found, or was just missing in some way. But you can see how problems cascade through publications. So, for example, the Shift project is citing the Andre and Edler paper, which is citing the Kurokan and Andre paper, which is citing Telecom Italia. And this failure of the availability and the transparency of the data in that original publication cascades all the way through to estimates in the more recent publication. You can also see the dates of these publications cascading through as well. So the Shift project in 2019 is relying on data going as far back as 2007. And this is important given how fast technology changes and the impacts that has on the reliability of the data. And you could ask, well, why does this matter? There are reasons within academia about why we would want to have accurate numbers. But to put this in a tangible way, a recent article from The Economist, and there have been subsequent articles in the Financial Times and other news organizations showing how data centers are causing problems as the grid is trying to provide new connections to other users. And data centers are often used as a scapegoat, and there is partially that in this article. But the argument is that unexpected demand from data centers and also battery storage systems has resulted in delays for the UK grid, and in particular in West London, providing new interconnection and also local connectivity to housing projects. And given the political sensitivity of housing, certainly in London at the moment, this is an interesting example of where lack of planning or lack of available information has resulted in real world problems for the grid operators and also people who want to buy houses. And the challenge that we have as researchers and other organizations publishing these numbers is that the ranges are so extreme that they just can't be relied upon. And that's why it's really important to understand how to produce reliable information and to actually get the data out there so that policymakers and people who rely on the electricity grid to provide capacity into the future can use that information to make planning decisions for infrastructure that has many years of lead time in terms of the construction and manufacturing. So to conclude, we came up with several recommendations in the paper. And these are useful for not just researchers, but anyone who is looking at an estimate number and trying to decide whether to use it or not. Now, although we say here that a publication that is several years making predictions into the future over several years is less reliable, 3 to 5 years, really any kind of prediction based on data that is more than a couple of years old is unlikely to be accurate. And this is just due to the speed at which you're seeing innovation and changes in the technology industry. So for example, relying on an estimate from 2019 would be completely outdated now due to the change in behavior caused by the shift to use of digital services from the pandemic. And the technology is also particularly important given how quickly that changes. Processor types, workloads moving into the cloud, and even once they're in the cloud, using different types of instances, processor types, and particularly relevant for, I think, the next few years, the shift from Intel-based processors to ARM architectures. And then just making those predictions out into the future. If anyone's ever looked at financial projections for a startup or even just a mature business, you'll know how unreliable those can be once you go more than 12 months into the future. So making predictions to 2030 and later is almost a waste of time, I would say. It's impossible to predict how these trends are going to change over the next couple of years, and we risk making policy decisions on data that is completely wrong. Making a decision based on 8,000 terawatt hours of energy consumption is very different from making a prediction based on, or decision based on 200 to 300 terawatt hours. Thank you very much.
Thank you very much. So is there a question for you? Is there any question for David? So I'll
just around the front.
You come here, okay? And so maybe I have a question.
Sorry, a question after you.
Yeah, no, I have a question for David, and then we start the panel, and David takes over. So the question is, you mentioned bottom-up versus top-down and estimates, and I understand perfectly that, of course, estimates allows to go over the time, etc. But trying to connect your talk to the talk by the other David, what is your feeling based on your experience? Do you think the measurement approach that he is developing, is that one something that could be useful also for in the context, for instance, of estimation, and maybe could give more precise results?
Right, so often estimates are made based on multiplying data or usage by an energy intensity factor, so kilowatt hours per gigabyte, or kilowatt hours per unit of data. And generally that produces incorrect results for most users. It is useful where you're trying to allocate the energy consumption over a known quantity of data, and you know the total quantity of energy consumption. So it's useful for reporting, for example, where you already know the energy, you already know the total amount of data, you can produce an energy intensity figure. But it doesn't represent the reality of how networks work, for example, and the underlying complexity in data centers in general. And so you have to be pretty cautious about using those types of numbers, certainly for predicting into the future, but then if you're making historical estimates, understanding what it's representing. And so using something like the cloud carbon footprint calculators does provide an accurate estimate of your historical usage, because the cloud providers have the total consumption data, but projecting that out into the future is going to have significant unreliability. And this is the challenge of the results from projects like the Shift project, where they use the baseline, they assume a few things, but in insufficient detail to be able to get the granularity and accuracy of the predictions that they make out into the future. And that is particularly challenging when you're trying to understand what's going to happen, because you do need to make these predictions. But if you estimate 8,000 terawatt hours and it's actually going to be 200, then your prediction is not that useful. And the latest publication on data centers in particular shows that energy consumption, which basically means electricity, is plateaued and is not going to increase significantly over the coming years.
Okay, so thank you. Now we move to the
let's move to the discussion, and it's great. I've got all four of the speakers lined up here, so we can start off. Of course, we've heard a little brief summary. We've heard about data centers. We've heard in some ways about some of the ideas around actually how we understand some of the life cycle assessments, and then there's discussion about a framework to assess the full ecosystem impact of software and services. I'm gonna draw back, and you slightly had this, Vasilios, from the point of view of social. I'm going to draw this back to the people. You know, the people that use a lot of these services, of course, they have an aim and objective of what they want to achieve, and in many cases, this does not take into account the amount of energy that a particular service uses. I remember, David M., that we had a conversation many years ago, actually about, of course, the impact of high resolution video conferencing, and how that is actually, you know, that has hidden utilization and hidden energy consumption. So how do we make the consumer aware, and what import should we put on within the 5 R's that I think, David E., that you showed? You know, within those 5 R's, the responsibility for some of those being the consumer, and some of those being the provider, be that the software provider, the hardware provider, or the connectivity provider. How do we share out that responsibility to actually have a successful overall achievement of actually reducing our impact? And I'll start off with Ilias, because I think this maybe sits slightly more with you, but I think then I'll just go around the rest of the group.
Yes, that's actually the top question that we're dealing with now, because there is a trade-off between the social issues, because you have a telemedicine, you have teleeducation, you have teleworking, and you cannot say, well, that spends too much energy, don't do that. So the social value, I come back to the three-dimensional space optimization. The social values, and that's what people experience, is very important. But the people themselves go into rebound effects and behaviors that they are not aware of. So there is a big issue on educating and measuring. But to educate somebody, you have to have a measure, and that's where all the previous discussions come in. So France is the only country in Europe that introduced already kind of a law that gives the telecom consumers the footprint of their, basically what they do with their mobile phones and with their telecommunication services. We in Europe, we're looking at, you know, is it, you know, that's based on ADEME measures, and David can give you all the details. How reliable is that? And at the end, if you give CO2 to people, so what do they do with it? So first, let's make sure that it's correctly done before we tax it and measure it and try to influence behavior, but also what kind of behavior you want to stimulate. Because in teleworking, there are actually studies that it saves energy. Of course, then it's still open question with respect to, you know, how much of a individual house heating we put in the picture. But even with all of that together, there seems to be savings. There seems to be savings with making global conferences to be hub-based. So every continent to have a hub and virtually link all the people instead of making them run over to one location. So all these studies have been done, but there are rebound effects, and those rebound effects are not obvious but overall, we need to make sure that we have a social and environmental, that whatever we do not harm the environment. We do not harm the environment. And that will become so strong that there is Greens in the parliament that will start putting, I mean, objections like red lines. We cannot cross this line. And that's AI kind of deployments. It's 5G tomorrow, 6G deployments. They will be looked at from environmental and social point of view. Do we really have a net positivity on both environment and social issues before we deploy that? Because that's normally kind of business models, more capacity, more telecom, more that for economic reasons. So all that is now turning upside down and questioned. But I have no really metric or kind of a framework that has it. There is one initiative, Digital with Purpose, that will launch this framework actually 27th of September in Lisbon, where they try to square the two dimensions.
Okay, David E., do you have something you would like to add on this one?
Well, actually, I think that it's an error to think about like the unit of impacts, like to try to attribute impact to each unit of services, to each unit of economical value, because like what people, as Ilya said, people cannot do anything with it, because it's not as people at the choice, you know. Usually they have a lot of constraints, social constraints, economic constraints, political constraints, and we should more focus on those constraints and which constraints could be used to limit the impact of environmental impact of ICT, and what constraints should be put in to limit the rebound effect when you deploy a digital service or a digital technology that is supposed to reduce the overall impact of a country. So we should more focus on the social dynamics rather than the unit of impact.
So if I may, just what you, David, saying, it's actually what the UNFCCC is trying to do. Let's define the needs. And there are some fundamentalists that say even mobility is not a need, it's just a satisfier. So what are the needs that we want to serve with digital in a way that it has the minimum environmental impact and maximum net effect if possible?
Okay. David? Other David?
I think Ilyas's point is a good one. And what are you going to do with the number that you get when you're looking at the reporting? So just as an example, if you run workloads on Google Cloud, you've got their cloud carbon calculator. It tells you the associated carbon emissions with your resource usage, but actually it nets to zero. And Google gives you both numbers. It gives you the number that it would have been, but the number that it is because of what Google is doing with those emissions. And the spectrum of that is quite interesting because it ranges from carbon offsets, which have significant challenges, all the way through to their goal of getting to 24/7 renewable energy 100% of the time. And at the moment, we're kind of in the middle of Google's been net zero for over a decade, but that doesn't mean that it's using clean energy to power its data centers. And it is doing various things such as buying power purchase agreements and renewable energy certificates to try and offset your emissions. So if you give that number to an organization, they can either do that work themselves, and is it more efficient for all of the millions of Google's customers to try and do something, or is it better just to outsource it to Google and let them deal with it? And there are certainly arguments for both sides, but it really comes down to whose responsibility are those emissions and where do they appear in your various scopes.
Okay, Vasilius?
Just to add to what has been said so far. For me, the root of the problem is that we haven't looked, and from an academic perspective, so we haven't really looked into the relationships between the different aspects, different dimensions of sustainability. We don't have any serious studies on exactly this, even these trade-offs. I'd like to think them more as feedback loops with each other, and then terminology I'm using is intentional. It comes from the system dynamics field. We know that there are relationships like this, and even if we take the environmental aspect out of it completely, right, there are still these relationships. So if we look at the classical work on technical sustainability, for example, of software systems, there are discussions about cost versus maintainability of a system, right? Like how much, at which point can you avoid paying developers to work on a system just to maintain it? At which point it stops making profit, for example, right? All these things that we're discussing in the 90s, basically, about how do we manage projects in this direction. So if we're talking grand picture of the field, what we're missing is exactly this kind of explicit modeling of these relationships. Collecting data, right? It shouldn't be an academic exercise. It should be something that is purely stemming from looking at long-term running projects, for example, in this case, actually monitoring data, looking at these studies that Lias, I think, was bringing up before about mobility versus using the virtual environment, and so on. So we do need a larger program basically on this. That's something that allows you to look at the bigger issues, both social and economic and technical and environmental involved. That's basically my message.
So yeah, so you're proposing this within the project that you mentioned. You're proposing this framework for a multi-criteria analysis, or a multi-criteria life cycle analysis, really around software. And it struck me actually that there's a lot of capability, or a lot of capacity for thinking about this in the broader. So going beyond the software and starting to look at how we can use a similar approach in other things. How easy do you feel it would be to do that? Maybe, let's start just the software and start thinking about the communication side, because it always strikes me that that's one of the parts that, though the French appear to have a solution here, and I'd be interested to see how they deal if a French person travels somewhere else and all that sort of thing. The communications network, the infrastructure, and how that's the energy utilization of that and its whole footprint is a really interesting and challenging one, particularly because a lot of this infrastructure lasts for a very long time.
Are you talking about the telecom industry, right?
Yes. So,
yeah,
the underlying network.
I agree. And having worked with some telecom companies, I wouldn't say providers, no, at least not in their provider capacity. Doesn't matter. Too many NDAs to talk about. But what I meant to say is, having worked with some of the telecom providers, I can tell you that even the network infrastructure itself is probably one of the least studied ones in terms of emissions, right? Like, there are some figures. I think if you start looking at papers like the other David was talking about, if I'm really tempted to do a study like this, to ask students to do a study like this, because it will be an even bleaker picture about what numbers people are using when they're estimating network footprint. There's basically just one very popular study that just cites a number which basically comes out of nowhere, and since then everyone is using it, right? And you're just looking at this and you say, okay, but I have no better way of.
Well, that's a really interesting and significant challenge, isn't it? That data accessibility, that data availability, and I think all four of you have mentioned actually the importance around correct provenance of data and how we might achieve that in all of the different aspects of what we do.
Yeah. So the problem particularly with network is, like, while you're monitoring, for example, server infrastructure, you can always say, okay, so this server belongs to company A. It only runs software from company A, so I can attribute some footprint on this. But with network, there's no hiding behind it. Like, you don't have exclusive usage in the majority of cases. So the whole issues of responsibility and even accountability within the energy usage of a simple device becomes already incredibly complicated to deal with.
Just to let you know that there is a regulatory agency, BEREC, that that has its own national, of course, regulators. And we just discussed, it's 1 year that they woke up to this question, and they are actually looking how to estimate the footprint and how to drive it. And they have two major goals. One is, how can I show that I'm doing like the data centers? How can I develop code of conduct so I can get sustainable finance to do something greener? So if I do this, I can get sustainable financing to do that. And can be fiber, it can be different software, it can be different, technology. And the second one is, what kind of numbers, because we committed as a commission that you will have to give numbers to consumers. Then we will have to see what to do with that. But what the French did, we kind of committed, we will work with the telecom providers, to give people the indication of what they're doing, because it's actually the user viewing of the high definition streamings and all that stuff that is behind the 80% of the footprint of telecoms. It's the users' behaviors. So those two things, they are struggling how to, as regulators, to minimize the footprint of the licenses they give, the sharing of the infrastructure, kind of helping the consumer in the right direction, but also greening their own infrastructures. And it's incredibly complex just to understand where to start.
Okay, well, just to wrap up this particular panel before we close completely, because we are running fairly late. If I ask each of you in turn, what's the most important thing you think that we can do in the next 12 months? And we'll go reverse order. So David M, I've given you the least time to think about this. I apologize.
I would say two things. I think move away from using data related to energy consumption. There is no linear relationship between demand and energy consumption. That would be the short term. And then long term is just improving transparency. And that is as customers of companies asking for the data, because that will provide a commercial incentive. And if that doesn't work, then you have to use the regulatory incentive, which I'm generally opposed to. But if they won't do it voluntarily, then forcing transparency, I think, is the next step. And I see it similar to financial statements. We have a consistent reporting standard globally for profit and loss, balance sheets, all those kind of financial analysis of companies. And it doesn't exist for environmental impact. That's only starting. But I think something similar to that, where we have consistent standards for transparency globally, is the goal.
Okay, Ilias?
I took it as a question to you as SWForum. Huh? What would you do as?
Well, it's okay. No, well, what would you suggest we do then? What would you suggest we do?
To a little bit understand the standardization landscape about what are the standards that evaluate the impact of the software. Because at the moment, I think there is either a lack or it's very, kind of heuristic to look at what is happening with maybe there are some ITU standards, L1400 series. There is, where is this, ETSI standard. So look at standardization. Can we standardize some of that thinking that we are just describing here? Can we put it in kind of a standardized way so people can, establish building blocks on which we can build and progress? Otherwise, I'm afraid 1 year from now we'll have the same discussion.
So monitoring and reporting, standardization, and things like that.
Yeah, I mean, when the standards in developing in a greener way or whatever you're discovering, to kind of see how it reflects with the standardization and de facto standards if needed. Yeah.
Okay. Vasilios?
I don't know what we should all be doing. I know what we will be doing in the next 12 months, which we basically engage in the stakeholders, right? Trying to find actual cases, try to collect, taking care of the provenance of data, basically. Okay,
and David E?
I think that we should shift from like an attributional way of accounting for impacts, where you want to account for the impact of each unit of service or each unit of production, to a consequential approach. And it's very important because digitalization involves transformation of all the other services or the other production, and we need to account for it. It involves a rebound effect, indirect effect. So we need to have a new way of thinking of the problem, where we look at the consequences of implementing technology rather than looking at the attribution of the impact of this technology. And this is the topic of my PhD, so that's why.
Okay. Well, I'd like to thank all four of our contributors to the workshop today. Thank you very much. What I have realized is that Ilias and Vasilios and Elisabetta, I'm afraid you have the wrong name, and you should all be David.
David,
so thank you very much, everyone, and thank you.
We can take care of it. We can take care of it.
Just 1 second. I want, sorry, just 1 second. I wanted to tell you that actually we have the opportunity, if we want, to publish post proceedings as part of the GECON post proceedings. Of course, this makes sense if you are interested in developing some papers coming out from this discussion or from what you are doing. And if yes, we can assemble these proceedings and include them as part of GECON proceedings. This is what we can do. And these are, I think, proceedings published by lecture notes in computer science.
Yeah.
Okay, so we will follow up on this point with the workshop authors, let's say with the speakers. So you let us know if you are interested. Okay, sorry, I think I have interrupted Silvana.
Hi, Elisabetta. Hi, everybody. There were just a couple of points in the chat. I just wanted us to just get them before everybody rushed off. So I was just going to say that to David, but one was a point to Elias. We're trying to set up this technical working group on digital product passport. Elias mentioned that earlier on in his presentation. And you've gone on to the subject of standardization. I was thinking, can we try and tackle some of these points in this technical working group that we set up, and then Nick put in a question after some of the projects that you have been, well, I'll let Nick say that actually, he's on this call too, but.
Yeah, it's just a question of how, if there were many projects already looking to address this issue of standardization, and the progress that they're making, or is this a new topic that is covered in the Horizon Europe program?
So there are from our investigation or our knowledge of the software projects that we're supporting, there aren't any particularly that are working on this particular question. Whether there should be in future, you know, that's a very interesting point, and whether or not the JRC needs to do something in this area, for example, or things like that, would be another question.
Thanks. Very interesting, by the way.
Good. I'm glad glad everyone online has enjoyed it. So thank you very much for your participation today. And as we said, we will be in touch with the four contributors around how we can actually get documented. You know, you can document what we've done here, and probably get a position paper out of this as well. So thank you very much, everyone online, and thank you very much, everyone in the room.
Thanks for having us.
Thank you, David, for organizing.
Thank you very much.
And I'll see you in a couple of weeks.
Bye-bye.